Have you ever thought about how your GPS suggests the shortest route to your destination, or how social networking platforms find connections between different people? It's all thanks to a simple yet powerful algorithm known as breadth first search, or BFS. Breadth first search is a traversing or searching algorithm in tree or graph data structures. It starts at the tree root or some arbitrary node of a graph, sometimes referred to as a search key, and explores the neighbor nodes at the present depth prior to moving on to nodes at the next depth level. To understand BFS more clearly, imagine a tree or a graph. The algorithm begins at the root node, exploring all the neighboring nodes before moving on to the next level. It's like dropping a pebble in a pond and watching the ripples expand outwards, touching everything in their path. The BFS algorithm uses a data structure called a queue to remember to explore the next node. The algorithm dequeues each node from the front of the queue and enqueues its adjacent nodes into the back of the queue. This process continues until the queue is empty, meaning that every reachable node has been explored. In the context of a game or a puzzle, BFS can be used to find the shortest path to the goal. This is because BFS doesn't just look at the current state of the game, but also at all possible future states. This makes it a powerful tool in the field of artificial intelligence. In the field of network communications, BFS can be used to broadcast or traverse through nodes. It can map the entire network, including routers, switches, gateways, and so on. In web crawling, search engines use BFS to index pages. The algorithm starts from a source page and follows all links from that page, repeating the process for each linked page. In conclusion, the breadth-first search algorithm is an essential tool in computer science and artificial intelligence. It helps in finding the shortest path in a graph, solving puzzles and games, mapping network communications, and web crawling for search engines. Remember, BFS starts at the root node and explores all the neighbors at the current depth before moving to the next level. It uses a queue data structure to keep track of nodes to be explored. This algorithm is a key player in many applications, from GPS navigation to social networking platforms. So next time your GPS suggests the fastest route, or you find a long-lost friend through a social networking platform, remember that the breadth-first search algorithm is working behind the scenes, making these connections possible. And that's a wrap on the breadth-first search algorithm. It's simple in its approach, yet its applications are far-reaching, making it an invaluable tool in the world of computer science and artificial intelligence.